This morning I'm going to talk to you just a little bit of an overview of ONOS, just to make sure that everybody is reset on the same page, even though I'm pretty sure that most of you are already familiar with ONOS, otherwise you probably wouldn't be here. And then also I'm going to give you a sort of a brief glance at some of the functionality that we've built since we've released, and as well as also peek at what we have in mind for building into the future. And so clearly, ONOS is a platform for developing SDN and IT solutions for service providers, but also, of course, of other network operators like campus and data center operators as well. It's because it's aimed at operating on critical networks, mission-critical networks. It needs to be based on a fault-tolerant core, which is distributed, because it also needs to provide scalability and performance at the same time. So those three tenets are key to the architecture. It also needs to be built, as Bill alluded to, around strong abstractions in order to assure portability of applications. And it needs to be a flexible applications platform, because different deployments will require different solutions and different sets of use cases and applications built on top of the platform. So, as everybody knows, ONOS is written in Java. It's built on top of an OSGI framework and a container, specifically Apache Graph and Felix. And on top of that, we built it as a distributed platform, which is physically distributed set of compute nodes, but they are logically centralized. And I will talk more about it later. The cluster can be dynamically adjusted in size to adjust to different increases in workload or decreases. On top of that applications platform, which has nothing to do really with networking at its base, we built a networking core, a set of base abstractions for controlling networks and representing networks in order to have a sort of a standard mental picture for applications to work with. And then it's key to note that the ONOS networking core is designed to be as minimal as possible, because as I mentioned before, the different deployments will require different sets of applications, and it's much easier to add stuff than it is to remove stuff. So the ONOS networking core is indeed as small as we could make it. And instead, when we rely to add additional functionality, we rely on ONOS applications. So this is where a lot of value lies. Now, so ONOS, what do you mean by applications? So ONOS applications are these are on-platform applications that run within the same OSGI framework and the same process, and operate in a manner which is indistinguishable from the components which are running in the ONOS core. Now, those are components that belong to different classes of different tiers of the architecture. They can be low-level southbound drivers or protocol providers, or they could be network traffic steering applications, or they can be some utility monitoring tools and things like that. So, throughout the spectrum of the stack, the one can extend the core functionality really easily, and following the same patterns in which the core is built. Now, we have a plethora of applications as it stands today. You will recognize a lot of them. But the point here is not to talk about those, at least right now, but clearly they're the key. So ONOS can be extended not only within the stack, but also on the surfaces on the outside. So CLIs, GUE can be extended, as well as REST API. And the point is that the extensions should be virtually indistinguishable from what comes with the base product. The idea is to seamlessly extend these surfaces so that from a user standpoint, they can't tell the difference which is what. They just see the extended functionality. So as a brief retrospective, we started longer ago, and you got the older history from Bill and Uriel. But since we open sourced in December 2014, we open sourced only with 4 applications and 1 southbound plugin, which was OpenFlow, and with a minimal platform. But the idea here was that the code had to be clean and modular, that we can build on it, that it provide a stable platform. And since then, we've added, functionality in a couple of different areas, and different releases were focusing on either innovating or showcasing some use cases, but also there were releases that focused on further hardening the platform. Because it needs to be kept in balance, otherwise, if you focus only on developing new features, your production readiness can decrease, and so forth. So the key is that the coherence of the code base in the architecture needs to be maintained, but also needs to be a platform where innovation thrives. So at this point in time, I think we're on our, is it 9th release or something like that. There are about 80 applications, which include southbound plugins, drivers, and samples. And there are many different distributed primitives that can be used to build the application distributed cores. So as everybody knows, we've been releasing on quarterly basis. The first release was the AVIL set, where we just had the clean modular code base and protocol independence. In the following release, we decided to focus on performance, because although we had scalability and reasonable performance in AVIL set, there were a few things we were ourselves disappointed in, and so we wanted to focus on addressing those issues. In the third release, we demonstrated further use cases. Specifically, one of them was core, which is now its own separate project. And we've added additional core features and additional protocols with the help of many of our partners and contributors. And in break, this was time to focus on platform and reinforcing some of the sort of prototype features that were added as part of new use cases, and so forth. So you can see the theme here is that sometimes the platform is given attention, sometimes new features are given the attention, and sometimes we just focus on use cases and demonstrations, which then later on need to be hardened. So clearly the last 3 releases, which is Falcon, GoldenEye, Hummingbird, you can see, I'm not going to go through full details, but you can see the theme in here, where we added a platform capability for dynamic clustering and model extensibility and so forth. So let's talk about what's in current release that's currently underway, which is IBIS. Specifically, there are a couple of key initiatives that we're working on, and one of them is dynamic configuration of devices and services. Now, this is something where we honestly are a little bit behind, for example, behind Open Daylight, and so we want to close that gap. And the idea here is to allow configuration of devices, in the dynamic configuration of devices at runtime, to be conducted using Yang-based models and NetConf and RESTConf protocols. Also, virtualization is something that we started incubating, actually, I think in the Drake release, which is over a year ago, but that we didn't have a chance to give it our full attention because of other initiatives. And so we're returning to focus on virtualization. And the idea here is to provide, unlike the Nicira approach or OpenStack approach, we're wanting to provide virtualization that actually generates virtual networks which are SDN programmable. And we're working on this sort of under the brigade model that was discussed earlier. We're also working on UI scalability enhancements. Now, this is not necessarily from the standpoint of the user interface itself, but mostly from a usability standpoint. You can actually present thousands of nodes on a topology UI, but so technically they will get drawn actually rather fast. However, it makes it really makes it really difficult for human to be able to find things, organize things in a logical way. And so the UI scalability enhancements provide support to make this information more easily digestible to an operator, and I will talk more about that later. And also, As we're working with various deployment sites in research networks and other areas, where the intent framework is actually being used to provide, using the SDN-IP functionality to provide connectivity between various autonomous systems. There were a few features that were lacking, and so one of our focuses for this focal points for this release is to enhance the existing intent framework to be able to cover some of those deficiencies. So the near-term roadmap items, which include the ones in current release and beyond, are sort of the following prioritized list of high-level sets of functionality. I already briefly mentioned the dynamic configuration, and I will talk more about it in detail later. It's the virtualization, it's the UI scalability, it's in-service software upgrade, external APIs for off-platform applications using gRPC. It's further working and elaborating on a federation model, and then coming up with a second version of our intent subsystem, where we want to take some of our experiences from the current one and address some of its deficiencies and take it basically to the next stage. And also, even though I alluded to the separate platform and separate cores, they are for the most part separate, but there are still a few areas where they're tied together. And so what we would like to do is actually officially separate the distributed platform and network core separation into sort of separate projects. So let's talk about the dynamic configuration. The service providers have been asking us to introduce this capability because they have a need to be able to interact, specifically perform configuration, not flow programming. For flow programming, actually, we receive very positive feedback that the existing abstractions that we provide, which are flow rules, flow objectives, and intents, are actually adequate for programming the forwarding plane. However, as part of operating network, you can also need to be able to orchestrate and provision the devices and configure them as part of the initial setup. And this is where operators prefer to use sort of unobstructed view to the configuration of the devices. So if the devices are configured through YANG models, whether they're standard or proprietary, service providers want direct access to those models. Not direct as in means that they don't actually talk directly to the device, but they want to talk through the model, whether it is proprietary or standard. So if, for example, the providers are working with a vendor who gives them a specific set of functionality or tailored functionality, they would like to be able to access that without any sort of abstraction in between. And so this is something that we're building currently. We are building a set of YANG sort of facilities. They comprise of YANG compiler to be able to take the YANG models and produce the Java source files as well as some schema metadata, which then can be further compiled using JDK and assembled into sort of deployable extensions to ONOS. We're also building, as part of this, a YANG runtime subsystem, which can be used to dynamically serialize and deserialize external formats such as XML or JSON as it's fed through protocol adapters such as RESTconf, ConnectConf, or others into the system. And so the YANG runtimes helps basically to translate between different representations. And we're also, one of the key parts is the development of YANG store, which is what allows it to operate as a distributed platform for the distributed configurations platform, where, for example, an application can exercise control from one node in a cluster over a device that is connected to another node in the cluster. And also can happen in a fault-tolerant way. So, for example, if in the middle of an operation the node happens to fail, the operation will be resumed somewhere else in the cluster. And so that is what is expected, and that's what we're building in current release. It probably won't be ready in IBIS, but we are aiming for demonstrating some functionality in ONS timeframe which will be following the J release. One of the things I want to mention here is that despite the emphasis being placed on Yang and Yang, sort of Yang-driven model development, there's actually surprisingly few adequate tools for working with Yang today, at least in Java. And so we want to make sure we pay particular attention on developing sort of Yang tools which are really portable, are usable even outside the context of ONOS. So that's dynamic configuration. Now that applies not only to devices themselves, but also to be able to model interactions with ONOS or ONOS applications through Yang. So basically modeling services. Because service providers are interested in being able to interface ONOS with their own orchestration platforms using interactions which are governed by service model. So on the virtualization side, I've already briefly mentioned that we want to produce virtual networks which are SDN capable. What I mean by that is that in OpenStack, virtual networks are generally just amorphous collections of end hosts which have implied connectivity, L2, L3, or otherwise. But they have no structure to them, and they really can't be controlled beyond that. And the idea here is to provide almost the converse of this, which is a collection, which is basically a network with a structure, which can be embedded onto the underlying network either manually through configuration or automatically through computation. And that network has no inherent connectivity. But instead, the connectivity can be programmed using a variety of different means, either using some sort of an external protocol such as OpenFlow, or potentially via REST using abstractions such as flow objectives or intents. And the idea is to support arbitrary topology so that you can construct a virtual network which is as simple as a big switch or as complex as the underlying network underneath it using isomorphic mapping. Now, of course, since ONOS itself is protocol independent, means it abstracts applications from the knowledge of what underlying protocol is used to interact with the devices, the virtualization subsystem needs to follow the same pattern, which means we are more than just a pass-through to OpenFlow devices underneath. So the idea is to facilitate, for example, OpenFlow programming of virtual networks, which are backed by non-OpenFlow devices potentially underneath. So the idea is to follow the pattern of the virtualization being protocol independent. On the UI scalability enhancements, I've already gave a peek into this. The idea is to facilitate human interaction, and so to overcome more, not the technical limitations, but more the human limitations of being able to digest limited amount of information at a time. And how we plan to do this is through supporting nested layouts, which means that rather than displaying the entire topology at a single flat representation, we allow the administrator to segment the topology into more of like a tree layout, where you can imagine that a continental network can be, for example, divided into metros. Metro regions can be represented just basically a set of metro regions, and then you can drill into the metro region from where you can see potentially multiple data centers, from which you can actually see floor plans. You can dive it all the way to racks. So clearly, how nested is the structure, it depends entirely on how the deployment decides to represent that structure and represent their environment. But from a user interface standpoint, we plan to be able to support both visualization of physical layouts, which can be either geomaps or sort of site plans or floor plans, but also logical layouts, because for certain cases, it's easier to think of a network in a logical manner. For example, spine leaf network is much, there's a standard sort of mental picture that everybody has of what a core network looks like. As part of this also, even though our UI today scales really nicely and pans and zooms, as part of the zooming today, we zoom the icons on a map sort of in an unconstrained manner, which makes it a little bit difficult to represent different densities on the geographical maps. And so the idea here is to be able to sort of throttle the icon scaling to have a minimum and maximum boundary. And that way, as you zoom out, you can dynamically adjust the proportion of the icons versus the background map. We also are updating our glyphs that we use for both the buttons as well as the devices with the help of a graphics designer and community. And also, as part of the addressing the scalability, we also are going to be adding, not in this release, but in future releases, ability to do global search through the UI for basically through the entire network knowledge base. In-service software upgrade. This is a feature that has been actually on the roadmap for a long time, but we haven't simply gotten to it. But we view it as extremely important before we can enter service provider deployments in any scale, really. And the reason for this is we cannot expect a service provider to deploy ONOS without being able to upgrade it in a way where it does not disrupt their network. And how we plan to accomplish this, we definitely have a sort of story and plan for accomplishing this. And it goes roughly like this. It's the idea is that ONOS is distributed, it's a cluster. So basically we will take one node down, upgrade that node, bring it back up, have it join the cluster and repeat the process on the next node until all of the nodes have been upgraded. And the idea here is that you get the last one, ONOS is running a brand new version. Now, clearly, as you can see, this is predicated on being able to, on the new software, being able to engage in communications with the old software. So it requires what we call as portable serialization, something that can be something that basically can speak two languages at the same time. And for this, we intend to use something like GUE protocol buffers because it supports a protocol evolution mechanism. This is something that we have not embarked on yet, but we're hoping that with the help of the community, we can form a brigade and start addressing this together. Closely related to this is gRPC APIs, whose goal is to provide fine-grained access to off-platform applications. So today, ONOS certainly can have off-platform applications because we do have a fairly rich REST API. But the REST API is really not, while it's ubiquitous and it's certainly very useful form of communication between sort of distributed applications, it is not really a suitable one for high frequency and low latency interactions because of the cost of setup of the REST calls, especially if you consider secure REST calls. So this is where gRPC aims to overcome, and it's going to be used heavily in Google, which is certainly a significant vote for it, right? So this will, having this fine-grained ability to have applications engage in much richer set of interactions with ONOS. We hope to promote development of off-platform applications, which can then be deployed potentially using a variety of different distributed and orchestration platforms, such as Kafka or other sort of services which manage, microservice deployment. And this also will allow applications to be potentially written for operating on platform, but later time you may decide to run them off platform. And also clearly, you can develop applications which are written in a language other than Java. Cluster federation. This is something that the work has already started on this with the help of the Icona project, specifically working on a peer-to-peer variant. But we want to also develop a hierarchical model where where you can actually develop a supercontroller which interacts with multiple subcontrollers underneath it. The idea here is that rather than the peers, whether it's peers or children, really doesn't matter, that a control domain does not expose its full detail of to its peers or to its parents. But instead that the lower controller exposes only a virtualized representation of its environment and allows manipulations of only a subset of its functionality. That's key in my view, because otherwise, if you just propagate all of the information that you have yourself up to the parent or to the peer, you are essentially not getting any. You're not achieving any encapsulation, and you're not really achieving any scalability, because the bucket of information only gets bigger and bigger and bigger as you have more peers being federated or more children being federated with each other. So the key in here is to develop it in a way where that allows essentially a virtual network to be exposed to the peers or to the parent. The idea here is to support a model, not necessarily just a model where you have multiple different domains all operated by the same operator. This would be just a pure mechanism to achieve greater scalability. But we also want to be able to primarily focus on a more difficult problem, which is where you need to achieve interaction and cooperation between domains which are operated by different administrators and different potential operators. And which is why I think it's key to achieve some level of abstraction and virtualization, because you certainly wouldn't want some other control entity, administrative entity, to be able to control your entire network, right? That just wouldn't work. So it's not just necessarily about scalability, but it's also about abstracting and controlling the level of access that your peers have over your environment. And this is something that, at least throughout the last 2 years, we've seen calls for this from various research networks. Because imagine an environment where you have large volumes of data produced in CERN, in Switzerland, which then need to be processed in San Diego Supercomputer Center. But in order to get from Switzerland to San Diego, it needs to pass through at least one long-haul research network, or other, potentially other lease networks. And because of the large nature of the transfer, you need to be able to provision fairly wide lanes for transferring the data. And so this requires cooperation on multiple different domains. As far as intent subsystem, sort of the next version, we call it intent domains 2.0. The idea here is that this capability, let me rewind a little bit. Today's intent system allows introduction of new intents and new compilers for those intents to be able to introduce new primitives. So it's extensible sort of horizontally. But what we found out through experience is that it doesn't really lend itself to building intents on intents. So it doesn't really stack up. Plus, it's not very conducive to conflict resolution. And furthermore, it makes an assumption that an intent, that all networks will accomplish the same intent in the same way, which is clearly not the case. So that forced us to start developing, for example, connectivity intents for optical networks, which are different than those for packet network. And that clearly violates sort of the abstraction principle that we wanted to accomplish. But it ends up being a limitation of today's framework, and this is something that we would like to lift. And how we plan to accomplish this is by sort of picturing a network as a set of regions or domains, where the controller over a certain region is given autonomy of figuring out how to accomplish certain intents. And so applications will no longer need to be concerned necessarily about what type of network they're going to be crossing or traversing when they're asking for, let's say, point-to-point or host-to-host or potentially broadcast level intent. They simply express their intent as a primitive, either as a tunnel, as a sort of a broadcast funnel or any cast funnel, or potentially as a default route, which is basically a converging tunnel. And this way, that primitive is then given to the various domains that are going to be traversed, and they can each decide how they map that primitive onto their underlying network. So for example, if you're crossing an optical network where provisioning the circuits is expensive, but potentially subject to different constraints than on a packet network, you can take whatever steps necessary as a controller of that optical network. And so this will, this is hoping to provide applications with a little more isolation from having to know about the constraints of those networks. Now, of course, one of the limitations today of intent frameworks is also the fact that you can ask for an intent and either it will work or it won't. Of course, we will do everything possible, the compilers will do everything possible to make it work with the cooperation from the intent framework, but there will sometimes be conditions where it doesn't. Because you simply, let's say you've asked for just a little bit too much. But we offer no way of the framework telling you, you know, what you've asked for is almost possible, but not quite. Would you like this option instead? So it's very much like, for example, me saying that I would like to travel from San Francisco to Paris is actually 10 o'clock. And airlines say, no. It's not very helpful, but if they told me, you know, at 10:05 or 10:30, you could get a flight, and I'll say, okay, you know what, I'll take that. So there's a little bit of a negotiation that needs to happen. And so we would like to introduce into this revised version of intent framework ability for application to request, essentially, an intent and be able to engage in selecting from a possible set of choices which either meet the demand or come close to it. And so this sort of a big offer mechanism is one of the enhancements that we plan to have done on the intent framework. So last, the platform and core separation is, it should be fairly obvious here. There are a few places where today the logical separation is slightly violated, where we have few things together in same packages, which should be separated for historical reasons. And we thought that perhaps through a course of one release, once we have time to sort of focus on a platform, we would be able to separate the two. And why would we want to do that? For a number of different reasons. We've been in conversations with a couple of research sites like Fermi and Oak Ridge Labs, were among those who are interested in actually using the ONOS distributed systems platform for controlling not necessarily network, but controlling other resources in their data center. And so this is where we need to sort of separate the domain knowledge, which is the networking core, from the underlying platform. And we're very, very close to that. We just need to actually make it sort of official and formal by separating those into distinct distributed platform, applications platform, and networking core. We feel that this will provide also significant benefits in context of SDN itself as well. For when you know, for example, in the context of federation, you can actually run potentially slightly different flavors of ONOS using this. So clearly, there's a lot of work to be done. So how we want to get there is using the brigade model, because we want to harness the power of community. Clearly, the ON.Lab team itself is very, very small. And so we don't have necessarily the horsepower to accomplish all of these things. And so the idea here is to consolidate the community around some of these sort of rallying points, functionality. And we started to do that with dynamic configuration, virtualization, and UI scalability, as well as some of the deployment focus efforts. And so we would like to extend that model in the future to form more brigades around some of these enhancements, and And this would put ON.Lab and the technical steering team mostly in the role of shepherds for those projects. We clearly want to be still involved in terms of be able to have feedback on the direction in which way this is heading, because we do have certain sort of, I guess maybe picture in our mind of how we think this ought to be accomplished. But of course, we may not necessarily know the best in all cases, and so the idea is to work with the community to get this done. So the number of brigades, which is today is 4, we expect to grow in the future. So I certainly hope everybody will become involved, and I invite everybody to attend the TST meetings, because this is where we discuss a lot of the current and potentially future projects and directions. And so we welcome your feedback and your participation. So that's it for me. Hopefully I didn't run too long on time. And I think the coffee break is next, right? All right, thank you very much.